Electronegativity is defined as the tendency of an atom to attract electrons in a bond. The attraction is caused by the positively charged protons in the nucleus. The element with the highest electronegativity is fluorine. That is because it is the smallest atom and, in the second energy level, has the most protons in the nucleus. The lowest electronegativity is francium. Francium is a very, very large atom with many energy levels and very few protons in its outer shell.
Let's take a look at hydrogen molecule. Hydrogen is H2, which means that it has two electrons that are holding these hydrogens together. The electronegativity of hydrogen is 2.20. Both hydrogens have exactly the same electronegativity, which means that they are each pulling equally on the electrons. The electrons are shared equally between the hydrogens. We call this a nonpolar bond.
If we look at a diagram of H2, we see the two nuclei, which are shown here in green and blue, and the electrons in red. The electrons are directly between the two nuclei. The two electrons in the bond are shared equally, and this bond is called a nonpolar covalent bond.
Let's look at the molecule hydrogen fluoride. Hydrogen fluoride, fluorine has 7 valence electrons, hydrogen has 1, so we have a total of 8 valence electrons. To draw the dot structure for this, it would look like... Now, what we need to do here is substitute for this bond 2 electrons. If we look at our table of electronegativities, we see that hydrogen has an electronegativity of 2.20. Fluorine has an electronegativity of 3.98. Fluorine is pulling much harder on those electrons than hydrogen is, so these electrons will tend to go towards the fluorine, which means if we draw this, that we have a hydrogen, we have a fluorine, and in truth, the electrons are much closer to the fluorine than the hydrogen. This is called a polar bond. We say that the electrons are more towards the fluorine, and the fluorine has a partial negative charge.
So we know fluorine has 7 protons. When it's sharing 2 electrons with hydrogen, it has 8 electrons. However, the 2 electrons are not shared equally. The fluorine has the electron more often than the hydrogen does. It has more of that electron. So it has basically 7 protons and 7.5 electrons. When it has more electrons but not a full extra electron, we call this a partial charge.
The hydrogen has a partial positive charge because the fluorine has a little bit of extra electron, partial negative, not a full negative, and the hydrogen has a partial positive.
Here we have a graphic representation of the structure. Again, you see the red, which is the electron density, is much closer to the fluorine than it is the hydrogen, which has very little electron density. The fluorine is pulling much harder on the electrons. It has a stronger electronegativity. Here is another representation showing the partial negative and partial positive of the hydrogen and the fluorine, and the electron density. The electrons here are shown in a lighter orange.
Here we have a molecule of water. We have an oxygen atom, we have a hydrogen atom, we have a hydrogen atom, and these bars represent the electrons. There are 2 electrons holding the hydrogen to the oxygen, and there are 2 non-bonding pairs on the oxygen. Here we see the water molecule again represented, but with the electronegativity pulling the electrons, and we see the bonds. Here again we have the oxygen, here we have the hydrogens, and we can see that the electrons are being pulled towards the oxygen because the oxygen is more electronegative. And finally here we see the drawing, again with a partial negative, because the electrons are being pulled towards the oxygen in these bonds. The oxygen has more electron density than it should. It's partially negative. And the hydrogens are partially positive because they have lost the electrons. They are less electronegative. Finally, let's take a look at NaCl. NaCl, the electronegativity of Na is 0.93. the electronegativity of Cl is 3.16. You can see there's a huge difference. Chlorine has 7 valence electrons, sodium has 1, so we have a total of 8 valence electrons. If we draw a dot diagram of this, we'd have to do it slightly different. First of all, we need to see the difference between the electronegativities. 3.16 minus 0.93 equals 2.23. This number is greater than 2. This tells us that these electrons are not going to be shared. It's going to turn out that chloride is going to end up with all 8 of them. And sodium is going to lose its valence electron. It's going to have none.
This is called an ionic bond.
Right now, sodium has lost its electron, so it has a positive charge. Chloride has gained an extra electron. It has a negative charge. These are not partial charges. These are complete charges. Again, in an ionic bond, the electrons are not shared. Chlorine is pulling hard enough to actually take the electron because of this huge electronegativity difference. Here we see an electronic picture of NaCl. We have the Cl, which is smaller than the Na over here. We have the Na here. And you can see that in between the Na and Cl, there is absolutely no electron density. There is a space between them. This is because the Cl takes so much more of the electron, it actually takes it. In fact, we end up with the Cl- and Na+ in this ionic bond. We've seen 3 molecules. We saw H2. The electronegativity difference between the two molecules, let's see, 2.20 minus 2.20 equals 0. When the electronegativity difference is 0, we have a nonpolar covalent bond. We looked at HF. HF has an electronegativity difference of 3.98 minus 2.20, which equals 1.78. This is a polar covalent bond. The electronegativity difference is less than 2, but it's greater than 0. The third molecule we looked at was NaCl. The electronegativity difference between NaCl is 3.16 minus 0.93, which is 2.23. When the electronegativity difference is greater than 2, we have an ionic bond. The electrons are not shared at all. They are transferred. In a nonpolar covalent bond, we have no charges. In a polar covalent bond, we have partial charges. And in an ionic bond, we have a transfer of electron and complete charges.
Here we see a table which classifies the electronegativity differences as different kind of bonds. Electronegativity is actually difficult to measure, and different tables have different values. That's why these values are slightly different than ours. However, if the difference is between 0 and 0.4, we see that it's a nonpolar covalent bond. If it's greater than 2.0, it's ionic, and there's a transfer of electrons.